Hey, it's Nick and Yvonne, and Yvonne's behind the camera, but I'll start with explaining where everything is on the camera. So, simple, we have on-off button, nothing too complex, but now we can start getting into the basics. So, right here we have our focus ring, getting all our subjects in focus. Here's our zoom ring, get the zoom in for farther distance objects. Then we have the flash right there, and on the back it's really a screen and other miscellaneous controls to control our camera settings, like our ISO, shutter speed, and aperture. And then they call this area the body of the camera, and then the lens, so that you can interchange the lenses and take them off, as you can see, and put on different ones for different specific areas of shooting. So now I'll show you what goes into taking pictures. So you can see Yvonne's behind the camera, and we can get him in focus. Let's see. There we go. And there we go, that's one shot. And that is where everything's located on the camera.
So we're going to start talking about the physics of the camera, where the light enters, which is at the lens. And here we have a regular lens. It has a focus distance of 1/4 meter, which is the smallest amount of distance between the lens and the object that the lens can still focus at. And on the lens there is a lens hood, which is to reduce the flare. And the lenses are retractable, you can take them off. And here we have a telescopic lens. What a telescopic lens does is it has a really good zoom where it retracts a whole lot, and the only downside of a telescopic lens is it can't focus on objects close by. It has a minimum focus length of 1.5 meters, where this makes it good for shooting pictures of cities and stars and moons. And then the last type of lens is the macro lens. It has a really close focus distance. And the next place where the light goes is the viewfinder, which is where you see the object. And that's what we're going to talk about next.
So for the viewfinder, especially on DSLRs, this is one of the best capabilities of the camera, is that you can see exactly what the camera's seeing, unlike your phone where you're viewing the image on a screen, or on some other point and shoot cameras where you're just looking at a viewfinder from another angle. So the light comes in through our lens, as you can see, and then it goes in through the camera body, and then it bounces off this, they call it a reflex and relay mirror, right down in there, and it bounces up into, so we'll see the light comes in here, bounces off the mirror, then it goes up into, they call it a pentaprism, where it bounces off here and essentially just gets redirected out to the viewfinder right there. So when you take a picture, we'll have some footage here, and you'll see that the viewfinder goes black when you take a picture. And that's because when we take the picture, we'll also show some footage of that here. The viewfinder, or the reflex and relay mirror, it moves up to get out of the way of the incoming light, so that the incoming light can hit the sensor, not the viewfinder. So that's how the viewfinder on the DSLR works.
So the shutter works on the camera by exposing the sensor to light and opening and closing like a type of cover. And the speed of the shutter controls the amount of light that enters the sensor and controls the exposure of the image. And there are two types of shutters. There's the rolling shutter, which is like a little slit of light that's moving across the sensor, and that has its ups and downs, where you can get a faster exposure and you can get nice action photography, but It also results in the image at the top of the slit is older than the one at the bottom, and can also result in blur if the shutter is not fast enough when the object is moving at a certain pace. And the other type of sensor is the global shutter. And the global shutter, the way it works is it opens one flap up and then down, but that requires a lot of time, and as a result the exposure has to be a lot longer. Okay, so the sensor in the camera, it works the same way as your eye does, and the sensor is divided into many different pixels, and each pixel captures the photons as charged electrons as it hits the silicon on the sensor, and this then is converted into a voltage number, which is then read by the computer inside the camera and is then converted to ones and zeros to make up the image that you took with the camera. There are two types of sensors: the CMOS, or the complementary metal oxide semiconductor sensor, which converts the number of electrons hitting each of the pixels all at once, and this reduces the amount of power needed to run the computer that converts the amount of electrons into a voltage number, and also gets the job done quicker, but also results in a more grainy picture. The other type of sensor is the CCD, or the charge coupled device, and this converts the number of electrons in a single file line and results in a more clear picture, and it's used in devices that capture aerial footage and space photography, and this requires more power but also results in a better picture.
To explain the physics behind aperture, we first need to explain what depth of field is, and to understand depth of field we need to know what focus is. To consider an object in focus, the light rays emitted from a single point on our object that we're taking a picture of must reflect back into the mirror and intersect at the same point of intersection that they did on the object on the sensor. So humans inherently, our eyes aren't perfect, we're not robots, so we have a tolerance of focus, and that creates our circle confusion. So the circle confusion is essentially a range of diameters of intersecting patterns or circles on the sensor that our eyes will consider in focus. For our depth of field, we have three basic examples of ranging depth of field. So you can see our first image, we have all three objects in focus. It has the largest depth of field as the image has the most of the objects in focus, and then we can have we can change the depth of field to where only the center object is in focus, or only the back object is in focus, or only the front object is in focus, essentially moving that physical domain of focus from the front to the back to the center of the image. Now that we've explained depth of field, we can move on to aperture, and aperture is essentially the control of the camera's iris diameter. In effect, by decreasing the size of the iris diameter, we can see that it restricts the amount of deviant light rays that are entering the image or the camera and hitting the sensor. In effect, what this does is it only allows light rays that are going to focus exactly on the sensor as when they are emitted from the object. When we increase iris diameter, we decrease the deviant, or we increase the deviance of objects that form, or the light rays that intersect on the sensor. So we have a lot more light rays that aren't forming on the sensor, so that's how we get objects that are blurred, that are farther away and closer away if we're focusing on the center object, because we'll be getting the objects from the center that are in focus, but we'll also have other parts of the image that aren't forming correctly on the sensor within our depth of field tolerance or focus tolerance. Now that we have explained the physics behind the camera, we can then go into the three main settings of how we control light in the camera. Shutter speed is how long the sensor is exposed to light by the moving or opening of the shutter. So essentially, when you're taking action photography, when things are jumping up or you're holding the camera without a tripod, you'll want to run shutter speeds of around 1/60th per second all the way up to higher than 1/1000 if you're talking about something, or if you're taking a photo of something that's jumping or you're dropping something. But for long exposure, what we'll want to do is, since the camera needs a lot more light to form an image, we will have shutter speeds around 2 to 30 seconds or even longer than that, depending on the conditions of how much light you have and where the light sources are coming from. The next setting we'll talk about is aperture. Aperture is the control of the iris diameter inside of the camera, essentially allowing more or less light into the sensor. And what we can do with a larger aperture, essentially, larger aperture number means a smaller iris diameter, but essentially with a larger aperture number around 22 or 30, we will get almost the entire subject of the photo in focus. Whereas if we run lower aperture f-stop settings, then we will be getting one or two objects in focus and have a very narrow depth of field. The final setting is ISO. ISO is the camera sensor's sensitivity to light. When you're outside on a clear day with a good amount of light, you'll be running ISO settings around 100, but when you're inside or a dimly lit area, you'll be running ISO from around 800 to 1600. Anywhere above 1600 for ISO, you'll start to notice some grain in the photo, and especially at night, which is when you want to have higher ISOs, you'll start to see the grain even more. So we try to stick around 1600 or lower when taking pictures with ISO. By mastering the three main settings in the camera, you'll be able to set up your camera in manual mode with the perfect settings for any condition. Usually for action photography, we'll be running a shutter speed of around 800 to 1000 if your object is moving at a relatively quick pace, essentially 10 miles per hour or above. We will now show you some properly exposed action photography. For long exposure, we will have a shutter speed of around 2 to 30 seconds. And essentially, when you're taking long exposure or action photography, you'll want to have your shutter speed be your main priority, and then move the other settings around, essentially to adjust to keep the light balanced in the image. And now for some long exposure photography. Thanks for watching.